Welcome to Logic First. In this video, let's learn about nested if in C language. In the previous video, we saw the basic syntax of if-else. If some expression followed by a block of code. So if this expression is true, then this block of code gets executed. If it is false, then the code belonging to the else part gets executed. So when this code gets executed, the else part code is not checked at all. It is totally skipped. Similarly, if the condition is false, then this entire block is totally ignored and only the else part is executed. Here, between these curly braces, we can write as many lines of code as we want and there is no restriction to it. We just have to start the code with a curly brace, write as many lines as you want, and then close it with curly brace just to indicate that this if part is over. Similarly, for the else part as well, you just can write as many lines of code as you want. So writing an if condition inside another if is known as a nested if. Each of this if or the else part works exactly the same as we discussed, except that we are nesting many ifs here. Let's see examples, you will understand better. Let's take this very simple example to find the greatest of three numbers. We can declare three numbers A, B and C. Get the values of A, B and C from the user. Let's declare one more variable called max just to store the biggest of the three numbers. At the end we can print max. Now we have three variables A, B and C. First let's check if A greater than B. If A is greater than B, then we should concentrate on this part of the code. If not, then we can deal with that in the else part. So now let's consider that A is greater than B. From this we can conclude that B is not the maximum number. It has to be either A or C, right? In order to find that, we should again compare A and C. So again, if A is greater than C, then max has to be A. If not, it means that A is not greater than C, or in other words, C is greater than or equal to A. So in that case, max has to be C. Now let's come to this part. This else part is executed only when this condition is false, right? A greater than B is false. Only then the else comes into picture. So if A greater than B is false means B is greater than or equal to A. Or in other words, A cannot be the maximum number. It has to be either B or C. So now let's compare B and C. Here, if B is greater than C, max is B. Otherwise, it has to be C. Finally, you can put a printf to print the max value. I have just added the main logic here. Let's just see some examples for A, B and C. Say we have 8, 5 and 6. First we are checking if A is greater than B. 8 greater than 5, it's true. So the execution comes here and checks if A is greater than C. 8 greater than 6 is also true. So max is assigned the value of 8. Since this if was true, this else will totally be ignored. We know that else will be checked only if this condition fails, but here the condition is true, so this else will not be checked at all. Similarly, this if was also true, so this else will also be ignored. And the execution comes directly here. Here we have the printf statement, so max will be printed as 8 in the output. Now let's take A, B and C as 10, 11 and 12. So first A greater than B is checked. A greater than B, 10 greater than 11. It is false, right? So this if becomes false, which means Whatever is there inside this if block will be totally ignored and the execution directly comes here to the else part because this condition is false. Now, B greater than C. 11 greater than 12. This is also false. This condition we are talking about, B greater than C, this is also false. So this max equal to B will be ignored and the execution goes directly to the else part and max will take the value from C. Max equal to C, which is 12, and 12 will be printed in the output. Similarly, you can check for other condition. Even check by taking two numbers as equal. That will also work fine. I have given the comment as greatest of three numbers, example for nested if. I will leave the link for all the programs in the description box below. So here I have just given separated by spaces. In scanf as well, we have to give spaces between %d if we want to enter the numbers by giving spaces. Alright, then the same logic I have written. Let's just check for one sample. I'm just giving 850 space 674 space 981. The greatest number is 981. It works perfectly. Note that I have given curly braces after each and every if condition or the else block. As you know, these are not necessary at all because there is just one statement here within our block of code. After if condition and the opening curly brace, I have given a tab space before starting another if. Similarly, the code within that if is also given after a tab space. This makes the code more readable. This is the general standard that is being followed. Imagine if we don't give these tab spaces, what happens? The code will look like this and it is not readable at all. Look at this code. It is much better, right? So that is why just give a tab space after starting a curly brace, after if or else, or when you write loops. This is the standard that is followed. Also note that we don't even have to give this curly brace here. If I run the code, I get the answer properly. I only mentioned if you have one line of code, you don't have to give curly braces, but this looks to be 4 lines of code. Then you might wonder why didn't we give a curly brace here? This if condition comes attached with at least one statement after that. If an else is found, it has to be attached to this if. And of course, if an else is found, there should be at least one statement following that else. So all these are clubbed together as they are connected to each other. The compiler can actually figure this out and understand that this entire code belongs to this if. Let's write one more simple program to find whether a given year is a leap year. So we are going to get an input year from the user and check whether the year is a leap year or not. Generally, a year is considered as a leap year if it is a multiple of 4, which means that if you find year mod 4, it should be equal to 0. In that situation, it is definitely a leap year, right? You do have to check for one more condition. For example, if you are encountering a century, as in the year 2000 or 2100 or 1900, if you are encountering centuries like this, you do have to check for one more condition. The century has to be a multiple of 400, or in other words, year modulo 400 should also be 0. Only then we can consider the year as a leap year. So following this rule, actually 2000 is a leap year, but 2100 or 1900 are not leap years. Even though they are multiples of 4, as they mark the completion of centuries, they have to be a multiple of 400 as well to be a leap year. But these are not. Here we are finding modulo because I think at this stage you would know that modulo is nothing but the remainder that you get during the division. So when you divide year by 4, what is the remainder? That will be given by modulo. So when the remainder is 0, we can conclude that year is a multiple of 4 or year is perfectly divisible by 4. If the remainder is not equal to 0, it means that year is not a multiple of 4. So the first thing that you have to check is whether year mod 4 is 0. So if that year is a multiple of 4, then we have to write all the logics that we discussed here. Let's come back to that in a moment. Let's first finish off this else part. I'm writing the else part of this if here. Else, it means that the year is not a multiple of 4 at all. You are just dealing with some number like 2017 or 2019. It is not even a multiple of 4. So it is not a leap year at all. Let's first print that. Not a leap year. Alright, now coming back to this part. Now it's a multiple of 4. We cannot immediately conclude that it is a leap year. First we have to check whether it is a century. And if it is a century, we also have to check whether it is a multiple of 400. So first to check whether it is a century, if year mod 100 is 0, then it is something like this, a century year. So we do have to perform one more additional checking, which we can do. Else, it is not a century at all means we are just talking about a normal leap year like 2016 or 2020, which is not a century, but it is still a multiple of 4. See, we are here inside this if condition. The year is definitely a multiple of 4, but it is not a century like these years. So we can immediately say that it is definitely a leap year, right? Alright, now coming to this part. Now the year is a century like this. So we have to perform one more additional check to find out whether year mod 400 is 0 or not. If year mod 400 is 0, then it's a leap year. If not, it is not a leap year. So once again I am telling, if year mod 4 is equal to 0, if this condition is false, this else will be executed and immediately not a leap year will be printed. Only if it is a multiple of 4, we have to check so many conditions. First check whether it is a century. If it is not a century, then it's definitely a leap year because it is already a multiple of 4. We are inside this if condition. Only if it is a century, you have to do one more additional check of whether it is a multiple of 400 as well, because only then it is a leap year. If being a century, if it is not a multiple of 400, it is not a leap year. So here I have the code. I will again link this in the description box. When I enter 2100, I get not a leap year. You can check for a few more cases. This website called Code Signal, it's very good for practice. There are so many challenges and tournaments as well as arcade questions which you can work on at your own pace. So if you go select this arcade, you will have several programming tasks here. When you go to this core part, you have some very basic programs in the first part, and at the crossroads is basically to make sure that you have very good knowledge about if-else conditions. So you can check this and do some practice problems. Thank you for listening.